Welcome to eMath. In this video, we are looking at equations. An equation is a statement that one expression is equal to another. Okay? A statement that some expression is equal to another is called an equation. A statement that one expression is equal to another. So we will be looking at different types of equations, starting with the most basic one, which is the linear equation. First one, linear equations. Linear equations. So a linear equation is one that is of the form ax plus b equals 0. Okay? Any equation that takes this form is called a linear equation, where a is usually different from 0. So this is called a linear equation in variable x. A linear equation in variable x, right? A linear equation in variable x is of the form ax plus b is equal to 0, a different from 0, and a and b are constants. Okay, so how do we solve linear equations? So every time you get an equation, it's usually a combination of constants and a variable to solve. All right, so how do we solve linear equations? The easiest way to go about solving linear equations is just to isolate the variable. Okay, so you move everything else on the left-hand side to the right-hand side and leave the variable alone on one side. All right, that resultant equation is then called the solution to the linear equation. So in this case, for instance, if we were to solve for x in this linear equation, then we start by, first of all, moving b to the other side by subtracting b on both sides, right? And for an equation to remain an equation, whatever you do on one side, you must do the same on the other side so that you leave the equation unchanged. So it becomes ax plus b minus b equals 0 minus b, which is actually ax equals to minus b, which is then we then isolate x by eliminating a, and the only way we can eliminate a is to divide it on both sides so that it cancels, and we are left with x equals minus b over a as our solution to the linear equation. So that's basically how linear equations are solved. For example, given the linear equation 5x minus 6 equals 3x, we are to solve for x there, x being the variable of the linear equation. Excuse me. We want to solve for x. So in this case, x finds itself on both sides of the equation. So the first thing we do is to, first of all, collect like terms. Bring all the terms in x together and all the constants together. So how do we do that? We move the 3 to join the 5 on this side by subtracting 3 on both sides. So it becomes a 5x minus 6 minus 3x is equal to 3x minus 3x. All right, so the 3x's subtract each other, we are left with 5x minus 3x, which is 2x minus 6 is equal to 0, right? So now we have this linear equation in the standard form. We can then isolate our x. First things first, we move the 6 to the other side. So we get a 2x minus 6 plus 6 by adding 6 on both sides, right? so that minus 6 plus 6 becomes a 0. 6 then disappears on this side, which is what we want. And then next, we want to remove the 2. The only way to do that is to divide 2 on both sides. So practically, when you are solving a linear equation, whenever you need to remove a particular quantity from one side, you do the opposite of what that quantity is doing to your variable. All right? What do I mean by that? So in this case, 6 is being subtracted. So in order to remove it, we add it on both sides. The opposite of subtraction is addition. Here, 2 is being multiplied by x. So in order to remove it, we do the opposite of multiplication, which is division. We divide it on both sides. If 2 was divided instead, if this was x over 2 equals 6, in order to remove 2, we will do the opposite, which is to multiply 2 on both sides, so that these two cancel each other, and we are left with x alone on this side, which is our desired result. Okay, so that's that. We will see more examples when we look at the worked examples shortly. Now, the next type of equation that we want to be looking at here is after the linear equation is the fractional equations. Fractional equations. So a fractional equation is one in which the variable appears in the denominator, right? A fractional equation is one in which the variable appears in the denominator, right? For instance, this is a typical example of a fractional equation. So long as there is a variable in the denominator, the equation is fractional. Now, mind you, don't get it twisted. This equation, for instance, all right, is not a fractional equation. This is a linear equation. Although the coefficients are fractions, there is no variable in the denominator. All right, so this is not a fractional equation. This is a fractional equation. Take note of that difference. I've seen students make these mistakes over the years of mistaking linear equations with fractional coefficients for fractional equations. All right, okay. So in order to solve a fractional equation, how do we solve fractional equations? The easiest way is to try and eliminate all denominators, all right? By first finding the LCD. We saw this in our last video, all right? In the last section, lowest common denominator. Put all denominators together, combine them as 1, and then eliminate all denominators. So once you have eliminated all denominators, your equation will then reduce to a linear equation that you can solve using the method we just saw a while ago. All right. So that's basically how fractional equations are solved. Okay, if we were to solve this one, for instance, we want to solve this fractional equation for x. Okay, so the easiest way I can go about this is I have only one fraction on this side and one fraction on this side, so I can quickly cross multiply. All right, cross multiply. 2 times 5 gives me 10. Is equal to x times x plus 1. All right, and then my thing then reduces to an x times x plus 1 equals 10, which is x squared plus x equals 10, which is x squared plus x minus 10 equals 0. Okay, so it reduces in this case to a quadratic equation, which we can also easily solve for x using the trial and error method for factoring or the quadratic formula. Now we'll look at quadratic equations in our next section, which is 0.8. Okay, but that's basically how to reduce this fractional equation to a linear or quadratic equation. Now, alternatively, you can do this by moving all your fractions to one side of the equation, all right? By moving the x over 5 to the left-hand side, we get 2 over x plus 1 minus x over 5 equals 0, okay? Once you do this, what you can then do is to put these two on common denominator, right? And in this case, our LCD will be 5x plus 1, right? Then we know what to do with our LCD from last section. Multiply each term by the LCD and eliminate all denominators. So it becomes a 2 times 5 times x plus 1 over x plus 1 minus x times 5 times x plus 1 over 5 equals 0. All of this divided by our common denominator, all right? So this guy takes out this guy takes out this guy, denominators all eliminated. I'm left with 10 minus x over 5x plus 5 equals 0. Okay, and it then becomes, no, x times x plus 1, sorry. It then becomes easy for me to cross multiply and have it to be the 5x plus 5 goes that side and becomes 0. So my denominator is eliminated. I'm left with 10 minus x times x plus 1 equals 0. Okay, which still boils down to this very quadratic that we have here. Then we can solve for our x. Okay, now the next type of equation we'll be looking at is the radical equation. Radical equations, radicals. A radical equation is one in which the variable appears in the radicand, all right? The variable appears in the radicand. For instance, 2x plus 1 plus 5 equals 4. This is an example of a radical equation. The variable is in the radicand, all right? Now, common mistake will be to mistake this square root of 3x plus 2 equals 5. It's not a radical equation, all right? Notice that there is no variable in our radicand. This is just some constant, okay? Even though this radical appears there, the variable does not appear in the radical sign. So this is not a radical equation. Right now, I'm stressing this because being able to identify the type of equation will give you a clue of how to solve it. All right, being able to identify the type of equation is very important in knowing how to solve it. So you need to be able to, first of all, be able to identify what type of equation is this, then how do I go about solving it. Now, in order to solve radical equations, what you need to do is to eliminate all radical signs, all right? Eliminate all radical signs. And by eliminate, I don't just mean throw it away. You need to eliminate it mathematically in a way that you end up not changing the question, all right? So that you don't end up changing the question. So to go about this, for instance, all right, now to eliminate your radical signs, you have to isolate the radical sign then you raise both sides to the power of the index. All right. Always isolate the radical sign first. Otherwise, the radical sign will never go away. Okay. So in this equation, coincidentally, we only have one radical. Okay. In some, you have two radicals. So you isolate them. Move one to one side, move one to the other side before you raise both powers, both sides to the power of the index. By the power of the index, I mean, in this case, for instance, it's square root, so we will square both sides. In the case of cube roots, we will cube both sides. In the case of fourth roots, we raise both sides to the power 4 and so on. But in this module, we will not go above square roots, right? For solving radical equations, I think we will only do the square root radicals. Okay, so we now isolate our radical. So this becomes by moving the 5 to the other side. Isolate our radical by moving 5 to the other side. So the whole thing becomes square root 2x plus 1 equals 4 minus 5, which is -1. Okay, square root 2x plus 1 is -1. Now our radical is alone on one side, all right? So we can then quickly square both sides. Whatever you do on one side of the equation, you must do the same on the other side. We square both sides to then eliminate our radical, all right? We know by our laws of radicals that square root of 2x plus 1 is the same as 2x plus 1 to the power a half, all right? So if we raise this to the power 2, by our law of exponents, this becomes 2x plus 1 to the half times 2. The 2 cancels with this 1, and the power then becomes 1. 2x plus 1 to the power 1, which is just 2x plus 1. So this is how the radical sign actually disappears, right? It's not some magic. It actually goes away by the application of our laws of exponents, just like this in these steps. Okay, so from here now, the square and the square root sign will then cancel as I have illustrated here. It becomes 2x plus 1 equals 1. And this then reduces to a linear equation, which is easy to solve by isolating x. So 2x equals 0 and x equals 0 over 2, which is 0. Okay, so this is how we solve radical equations in which we only have one radical sign in the equation. Now, in situations where we have two radical signs, okay, 2x plus 1, maybe plus square root of x equals to 4, for instance, all right? What you need to do is not to quickly square both sides here. If you square both sides here, you will not be able to eliminate the radical still, all right? The squaring both sides, common mistakes I've seen students make over the years is to square like this and then say that it becomes 2x plus 1 plus x equals 16, and then they go ahead to solve. Wrong, okay? Very wrong. Remember that when you square in this manner, okay, squaring in this manner simply means square root of 2x plus 1 plus square root of x times itself. Okay, don't forget we did this when we were doing multiplication of expressions, multiplying algebraic expressions. We saw this, okay, that x plus 1 squared simply means x plus 1 times x plus 1. And then you go ahead and multiply in your brackets like that, all right? You multiply in your brackets like that and have your answer. Now imagine you squared both sides like this and then you do this, all right? This times this will quite all right be 2x plus 1. Radical disappears. But then this times this, radical will not disappear. It's going to be plus square root of x, square root of 2x plus 1, plus square root of x, square root of 2x plus 1, plus x equals 16. Okay, that's what this square becomes, squaring both sides. So you see that your radicals are still very much involved and even getting bigger. Okay, this is not what we want. So in order to simplify this, you need to isolate these radicals before you raise your both sides to the power of the index, all right? You need to first of all isolate these radicals before you raise both sides to the power of the index. Okay, so then in this case, I want to move the square root of x to the side. So it becomes square root 2x plus 1 equals 4 minus square root of x. Okay, now I'm ready to then square both sides. Square, square. Another common mistake students usually make will be to, at this level, instead of squaring everything, all right, I've seen where students, instead of squaring everything like this, they now come and square individually. Very wrong, all right? Because mathematically, a squared plus b squared is different from a plus b all squared. Very different. They are not the same, all right? So squaring both sides simply means squaring everything, putting everything together in one bracket and squaring all of it, not individually. Not individually like this. This is wrong. Okay, square the entire side like that. Okay, so again, by our laws of exponents, the square and the square root here cancel, and we are left with 2x plus 1 on this side. And on this side, we have to actually open up our brackets, all right? We have to actually open up our brackets the way we saw how to multiply algebraic expressions. So it becomes a 2x plus 1 is equal to 4 times 4, 16, 4 times negative square root of x, negative 4 root x, negative root x times 4, another negative 4 root x, and negative root x times negative root x is going to be positive x. Okay, I hope you understand why it's like that. Because negative root x times negative root x is going to be like negative x to the power half times negative x to the power half. All right. Now, negative times negative, first of all, becomes positive. All right. Becomes positive. Then, same bases being multiplied, law one of exponents says we should add their powers. So half plus half becomes positive x to the 1, which is just x. Okay, that's how my minus root x times minus root x gives me x. Okay, so your laws of exponents and radicals are very, very instrumental here. And that's why we started off with them. Okay, so that said, I can then simplify this to 2x plus 1 equals 16 minus 8 root x plus x. Now, I still have a root x, a radical in here that I need to eliminate, all right? So what I must do is to isolate this radical and square both sides again. Keep doing the same thing until I no longer have any radicals in my equation. Okay, so then we move everything else to the other side. We get we get a 2x plus 1 minus x minus 16 is equal to minus 8 root x. Okay, which becomes, collecting like terms, 2x minus x is x, 1 minus 16 is minus 15 equals minus 8 root x. Then we can square both sides, all right, to get x minus 15 squared equals 64x, like that. 8 squared minus 8 squared is 64. Square root of x squared, the square root sign and the square cancel, and we are left with xt. Okay, so you then have this equation that you expand this bracket the way we expanded this one, all right? And then you get a quadratic equation, which is easy to solve for x. So basically, these are the two types of radical equations that you will encounter and be able to solve. Then the last type of equation we'll be looking at is the literal equations. Literal equations. So literal equations are simply those in which constants are represented by letters. For instance, the formula for future value of a principal amount of compound interest future value formula, S equals P times 1 plus R to the N, is a typical example of a literal equation. So in literal equations, we only have letters. However, it's usually indicated which of them is the variable, right? So you could be asked to solve for R in this equation. So if you're asked to solve for R, it means R is the only variable and every other is a constant. S is a constant, will be treated as a constant. P will be treated as a constant, and N will be treated as a constant. All right. And if you're asked to solve for P, then P will be the variable and every other letter in it will be a constant. So that's how literal equations work. And you solve for the variable in terms of the other constants. So if we were to solve for R in this equation, for instance, the first thing we do is to bring P to the side, dividing both sides by P. P cancels. S over P equals 1 plus R to the N. The next thing is to remove the n by taking nth roots of both sides, all right? It becomes S over P to the 1 over n is equal to 1 plus R to the n to the 1 over n on both sides, so that n goes away. So we are then left with S over P to the 1 over n is equal to 1 plus R. Then we move the 1 to the side to isolate our R. So S over P to the 1 over n minus 1 is equal to R. And that's the solution to that literal equation. So literal equations are usually solved in terms of the other variables. So for the sake of, in terms of the other letters which represent constants. So okay, so we'll end this video here for now for the sake of its length, and continue solving problems on equations in our next video. Thank you.